In this example, we're going to do an application problem where we solve a system of equations. Let's read through the problem. A rectangular banner with an area of √3 meters squared, so we know an area, is being designed to advertise and exhibit at the Davis Gallery. The length of a diagonal is 2 meters. We need to find the dimensions of the banner. So we know an area, we know a diagonal, and we want to find the dimensions. Finding the dimensions means we want to find length and width. When we're dealing with an application problem, we always identify the unknowns first. In this situation, we have two unknowns. This means we must be able to develop two different equations or we won't be able to solve the problem. So let's think about what we know. We know the area of this rectangle. I'm going to draw a rectangle here. There's my banner. And when we think about a rectangle, if we were to mark this, we might say length and width. So we have two lengths and two widths. And what can we say about area? Well, we know the area of a rectangle is equal to length times width. So that means we have an equation, √3 equals length times width. We're also told that the length of the diagonal is 2 meters. So we know that this, I can draw a better diagonal than that, but we know that this diagonal here is 2 meters long. So we need to come up with another equation looking at this picture. In this situation, I'd be inclined to use Pythagorean theorem because we have two right triangles. And what we know is a leg squared plus a leg squared equals the hypotenuse squared. So 2 squared equals the length squared plus the width squared. And I set that up using the Pythagorean theorem. So as you can see, we have two equations. Essentially, we have a rational equation as well as this equation could represent a circle. I'm going to go ahead and take that 2 squared here. I'm going to rewrite that as 4. Now, these two equations aren't organized in the same manner, meaning we can't line up the terms and use the elimination method easily to solve this system. So I'm going to use the substitution method. I'm going to isolate a variable in one equation. For example, this top equation, I could say that W equals √3 divided by L. And I can take that √3 divided by L, since I know it's equal to W, and plug it into my other equation. So that's going to give me an equation with only one variable. I'll have 4 equals L squared plus √3 over L, quantity squared. So now we have 4 equals L squared plus 3 over L squared. Don't forget that that square is going to apply to both the numerator and the denominator. At this point, I'll multiply this equation on both sides by the LCD, which is L squared, which gives me 4L squared equals L to the fourth. L squared times L squared is L to the fourth, plus 3. Now we have a quartic polynomial. And when we're dealing with quartic, cubic, or even quadratic polynomials, we like to write them in descending order equal to 0. So I have 0 equals L to the fourth minus 4L squared plus 3. At this point, we look to try and factor this or use a U substitution. I'm going to go ahead and factor it. This is the same as saying L squared minus 3 times L squared minus 1. So if it's easier for you to use a U substitution, feel free to do that. I wrote my logic out for how I do that. So we set U is equal to L squared. So L squared squared, that's U squared minus 4U plus 3. It's easier for us to factor that. And then we would put that L squared back in, which brings us right back to where we are. Now, solving each of these equations equal to 0, we use the zero product principle I have L squared minus 3 equals 0, and L squared minus 1 equals 0. That's going to give me two options. I'll have L squared is 3, or L equals plus or minus the square root of 3, as well as L squared equals 1, L equals plus or minus the square root of 1. So this gives me four values, two which are positive and two which are negative. Now, we're measuring something and we don't measure distances in negatives. So what we can say is either the length equals positive root 3 or the square root of 1 would be positive 1. What would that mean for the width? Now coming back up here, remember we know the width in terms of length. The width in terms of length is W equals root 3 over L. Using that, W equals root 3 over L, that would give me W equals root 3 over root 3, which is 1, or W equals root 3 over 1, which is root 3. So the dimensions, the length and width, are interchangeable, but the dimensions of this would be root 3, and my units is meters, by 1 meters. And you may be asked to round, so you could type that square root of 3 into your calculator and you get an approximate value about 1.73. So I'll say 1.7 meters by 1 meter. Also, you can check this. So we should be able to check two things. I should be able to see that 1.7 times 1 gives me approximately root 3, or root 3 times 1 gives me root 3 because that was my area. And then root 3 squared plus 1 squared should give me my hypotenuse, or my diagonal squared, which is 4, 2 squared. So it should make sense. Always go back and make sure your answer makes sense within the context of the problem. As always, email me if you have any questions or concerns.